Hello, everyone. Welcome to this free cybersecurity webinar. My name is Olu from Stack Solution Inc. And today we are diving into an exciting and practical area of cybersecurity called penetration testing using Metasploit in Kali Linux. This plays an important role in security assessment and testing domain, especially when it comes to the CISSP framework domain with our cybersecurity certification. Now, in this session, we'll see how penetration testing aligns with the MITRE, ATT, and CK. And by the MITRE, ATT, and CK, we mean a globally accessible knowledge base for adversary tactics and techniques based on actual real-world observations. The CK also stands for common knowledge. Within our MITRE, ATT, and CK, we are going to be focusing on some key critical tactics and techniques, such as our credential access, our initial access, and our reconnaissance. For the credential access, we are going to be exploring brute force. And then when it comes to initial access, we're going to simulate how an attacker can gain entry into some of our server systems networks. For the reconnaissance, we're going to gather intelligence about our target environment, which in this case will be described as our client server. To bring all of this to life, we'll be working with two critical servers. The first one being a Kali Linux server, which has been configured and deployed using the Azure Cloud Computing. And the second being our target server, which is an Azure Windows 2025 VM, also configured and deployed within our Azure environment. We'll walk through hands-on demonstrations that simulate real-world attack scenarios in a controlled network environment. This will enable us to understand not only the tools, but the thinking process behind penetration testing, all within the context of the MITRE, ATT, and CK. So let's buckle up because we're going to blend theory with practical hacking techniques to give us an actionable understanding of how these concepts align in real security testing. So let's jump into it. Now, the very first place I want to kick off with is logging in remotely into our key servers. By that, we're going to be logging in into our attacker server, which is our Kali Linux server, and our target server, which is our Windows VM server. So I'll go ahead and get that done. The first is the attacker VM. Over here, I'm going to log in using what we call Azure Bastion. I'm going to go over here. Then I'll supply the username. I'll also supply a password, which is a asymmetric encryption using RSA encryption. And with RSA encryption, we are provided with two keys, a public key for encrypting our password and a private key for decrypting the password. Over here, I'm going to decide to grab our private key for my local PC. I'll select that option, load up the private key for decryption, select that over here, and then I will go ahead to hit the connect. Now we're successfully connected into our Kali Linux. On this Kali Linux, we have Metasploit already configured, installed, and ready to go. As such, I will initiate Metasploit to jump into our Metasploit environment. I'll do that by initiating the MSF console command, and I will hit enter on my keyboard. That should bring us into our Metasploit. Perfect. We are now into our Metasploit, and I will confirm that with our MSF6. We're going to take a pause there and we're going to log in remotely into the Windows server as well, this being our target server. Let's go ahead and do that. Now I already have an RDP connection file for our Windows server downloaded. So I'm going to go ahead to double click on that file and I'll present my password to login. I'll hit the continue, hit continue, and that should log me in. Now, the very first test that we're going to perform has to do with our SMB login. This requires the SMB to work with a TCP protocol to establish connection between the attacking VM and the target VM. Let me go ahead to adjust this properly. Perfect. Now, for this to work properly, from my Windows VM, I need to ensure that my network settings allow an SMB inbound network firewall rule. This is because from the cloud perspective, which is the outer layer for our firewall when it comes to network security groups, it would need that configuration. As we can see over here, I have a port 445 pointing to the protocol TCP enabled for SMB inbound. Also, if I go to the remotely logged in version of the same server over here, I'm going to check with our Windows defenders to ensure that I also have an inbound firewall rule set up for our SMB TCP protocol. I'll go ahead and launch that application. We'll expand that over here. And if I go to the inbound rules, I can confirm that I do have an allow SMB inbound custom rule for that. Furthermore, I can click on the properties to confirm that it is enabled and it is allowing the connection. I can also check on my protocols and ports. I can see that is set also to for a TCP with a local port of 445. So now we know that we have those established. Now for this specific test, what we are targeting is the MITRE ATT&CK credential access brute force. Let's go ahead and select that. In the case of our brute force, it tells us that adversaries may use brute force techniques to gain access to accounts when passwords are unknown or when password hash algorithms are obtained. And so our very first test here is to perform a practical penetration test using targeted usernames and password to see if we can break into the username and password of the Windows Server target VM so that we can seize hold of that VM by having the credentials and hijacking that client VM. To perform this, a few steps needs to be taken from our attacker Linux VM. So I'll go back over there. So now we are back in here. We're going to start issuing various Metasploit commands to perform these tests. So let's kick off with that. The first thing I want to do is to initiate a specific type of module called the auxiliary module. I'm going to go over here and I'm going to say use auxiliary scanner SMB login. This will bring us into this specific penetration testing module for our SMB attack. I'll hit enter on my keyboard. And now we can see we're no longer looking at MSF6, but rather a specific module called the scanner SMB login module. Now, the next thing I want to do is to set the attack on my target VM, that being our Windows Server client. For that, I need to be aware of the private IP of that server. When I head back to the client VM, I can see from the network settings that the private IP is 172.18.0.5. So I'm going to go ahead and set a roast target on this VM. And so the command for that is set roast and then our private IP of our target VM. As you can see, that is 172.18.05, 172.18.05. So let's go ahead to initiate that target. Now the roast has been set on our target VM. Our next step is to set a username for this attack. Once we initiate the username, we will then set another file that contains and utilizes that username with several different types of passwords that we're going to use as a brute force attack against our client's VM. But before we do that, let's go and quickly examine some applications within our client server's remote logged in environment so that by the time we start performing our test, we can collect valid information to confirm that our penetration testing is going through and that we can see the results of those activities. I'm going to quickly navigate back to our remotely connected Windows VM. Back here, we're going to launch an application called the Event Viewer. I'm going to open that up. And then from our event viewer, we're going to go to our Windows logs that collects critical system information and events. And I'll select security right there. And we'll wait for that to pull up with some information. Okay, perfect. So right now we are seeing some event activities, some success and some failures as at 5:21 a.m. But over here we can see some current activities in here. We're having some failed credential audit failure issues over here, that being from other different activities, but we're going to see how this works with penetration testing. I'm going to go ahead and clear log and hit clear right there. So we can see right now as of 5:22 a.m. that there's an audit success on this system. By the time we kick off with our penetration testing, we should start seeing a whole lot of audit failures based off credential logging failure. So let's head back to our Metasploit Kali Linux environment. Now that we have this all set up, targeting our client VM that we just took a look at, I'm going to come back over here and I'm going to set the username as the administrator. I'm going to come over here and say set SMB user, and I'm going to provide the username as admin scarstack. I'm going to hit enter on my keyboard. Now that that has been set, we now need to call and set a specific file that Metasploit will gather together for us that has hundreds, if not thousands, of username passwords that can be used against our client VM for a brute force attack. To put that together, I'm going to issue some commands over here. I'm going to say set pass file, give it a space, target a path, USR for user, and I'm going to go with share. I'm going to say Metasploit framework. And then I'm going to go with data, word lists, and then the specific file, that being unique passwords, or Unix passwords rather, .txt. With that command in place, I'm going to hit enter. And now we've set a pass file where it's going to go and utilize our username with different variations of password is going to use as a brute force attack against the client's VM. Do bear in mind that as we still go back over here, nothing much has really happened. I'm going to go back over to our Metasploit environment, and then our next command right here is for us to perform the launch attack. I'm going to go ahead and hit a command called run. Do bear in mind that we have two main types of attacks over here. One called run and the other called exploit. An exploit is a more exclusive direct attack on a particular server or host. A run is a more soft attack that doesn't directly target our server, but then reaches it to just perform an initial soft attack. Since we are especially using an auxiliary module rather than an exploit module, it is best for us to go for the run, even though we can also initiate an exploit. Now that we're ready for this, I'm going to hit enter on my keyboard and it's going to begin the brute force attack. Let's go ahead and hit enter on that keyboard. So now we can see it's starting the SMB login brute force and is beginning to try different username and passwords against our Windows client VM. Majority of them are failing because that is not the right user credential. However, the brute force attack is going to continue to generate different credentials to attempt to perform a brute force attack on our Windows client so that it can gain control over that client's login credential and login by itself to our full access control. Within our client server, when I hit the refresh button, I can see different audit failures that are already occurring based off our penetration testing on the brute force. By simply selecting one of these as an example, I can come down and start monitoring, and I can see the account name admin stack, which matches with our admin stack over here. As we can see, Metasploit continues to penetrate our Windows client server with a brute force attack to guess different passwords. Back over here within our server, I can see one of those examples. I can see the category is a logon where it's trying to log in. It's confirming it's an audit failure on our client VM. I can also begin to go down and see other attacks right there. Right here is another one that says the account name that is trying to infiltrate this Windows client VM is our admin stack. The failure reason is an unknown username or bad password. And so the Windows security logs within our event viewer begins to allow us to track this in real time. And so a few key things are going on over here. This our Kali server that has Metasploit is running those attacks and is trying to hack into our Windows client server. Now this will continue to work for several minutes till it gains full attack over our server. If it's not able to, based off the username, credentials, and password that it supplies from that file that we initiated, at some point it's going to stop and let us know that the brute force attack was unsuccessful. Now this is going to run for some few minutes. So while it's doing that, let us get some full understanding. When we started this specific attack, it started off by saying starting with an SMB login brute force. That confirms to us that the module which we're using called the SMB login is configured correctly and has started our attack. Furthermore, we begin to see the failed on our specific targeted client VM using the TCP protocol for our SMB. That also shows us that this is the most important part of our line in this command. This means that our scanner successfully connected to our SMB servers on that particular VM. And it tried to log in with the username scarstack admin, or rather in this case, admin scarstack, and it tried to use multiple passwords to log in. Furthermore, it is showing us all of those variations of passwords, and it is not yet getting the right password. The result eventually is that the scanner is going to go through all of these many passwords using our Unix underscore password.txt file that we saw some minutes ago. And every single one of them are most likely going to fail. This simply means that the correct password for our VM is not within this specific text list. And so that is a very, very good example of how we can perform a brute force attack on a targeted VM. And then If we take a step back to our desktop right here, which is the remote desktop that is logged in into our target VM remotely, and I go ahead and hit refresh, we see that the audit failure continues to occur. If I select the latest one right here as well too, I can see it right there. What this tells us is that this is a direct evidence or forensic footprint that is being left behind by our successful brute force attack. We are now looking at that attack from the victim's machine's perspective. And that is the result of the attack we just launched some few minutes ago. And so a few things are going on over here. First of all, a massive flood of failed logins, as we can see that going on over here, even at this very moment. That screen that we're seeing right here is filled with attacks that are coming into the screen here within our audit failure realm. The second thing is the mark of an automated attack. When we look at the timestamp, it tells us that that is even going on in seconds. So that is very, very critical. No human being could type passwords like this that fast. This indicates that the attempts were made by an automated tool, in which in this case is Metasploit. Now, another key thing is to understand the specific attacker and the targets. Within our area over here, we can see the attacker's name being provided over here using the account domain. And as we go down, we can see more of those correlated results and information. Furthermore, it also provides the attacker's private IP address. We know this is true because when I look at 172.18.04 and I head back over here and I go back to our VM for the attacker, I can go to the network settings and we'll wait for that to load up. And I can see that exact number, 172.18.04 for our Kali Linux virtual machine, 172.18.04. We head back to the client's remote VM. I can see that right there. It also shows us the source port login information. So some key things to be aware of. As we go down, it begins to show us even more critical information about this specific attack. And so that is very, very important for us to be aware of. Below here, we can see the client's VM separated from all of this inner information. And that is our client VM right there. VM client target, the VM client target. So that is very, very important. Now, let's go and take a look at another example. And because this is still busy right here at the moment, we're going to open up another Bastion session. I'm going to go back to Bastion. I'll click connect over here once I've provided the right details. Over here, I'm going to select local file. I'll select the file to decrypt from my private asymmetric key. I'll select that from over here. Hit connect. That opens a second Linux session. I will initiate Metasploit from here. Hit enter. And I will start up the Metasploit framework console for us. Perfect. Now we are in there, we can see our MSF6 has loaded up. Now, we want to do another quick test. In this scenario, we are going to be exploiting an unrestricted file upload vulnerability. This is going to target any website that has been deployed on our web server for the client VM. In our client VM, we've deployed an IIS web server, and so our Metasploit is going to seemingly attack that, and it's going to look for any space within our VM where there is a poorly configured file upload feature within that server or website. It will then escalate privileges to take full control of the VM by exploiting it through that particular feature. And so let's jump into that. That is going to give us our reconnaissance MITRE ATT&CK attack. In this case, we are looking at it as reconnaissance and enumeration, the concept of information gathering on a target or client VM. Now, let's go ahead to initiate that process. In this case over here, because I want to perform a direct scan, I'm going to use a different module. I'm going to call this use auxiliary scanner HTTP direct scan dir underscore scanner. Now we'll switch to that particular module. I will enter on my keyboard. Perfect. Now we are inside that auxiliary module. Now for this, I also want to now set our target VM. I'm going to go ahead and say set host, and then I'll provide that. That should be 172.18.0.5. But let's double check on that. I'll go back over here to the client's VM, and I can see the private IP 172.18.0.5. Come back over here, 172.18.0.5. With that confirmed, I'm going to hit enter on my keyboard, and we've set the target VM. Now I'm going to initiate the attack, or as we say, launch the attack by using the run command. Let's go ahead and hit that. We'll wait for that to finish loading up. So far, so good. Everything is working well. So we can see from this particular result from the launch attack, it started to say detecting error code, and then it brings out another information saying using code 404 as not found for that private IP of our target VM. And it confirmed that it did scan 1 out of 1 host, that being the fact that we provided only 1 host. So let's break down what we are seeing over here. When we're looking at this fact here that says detecting error code, it tells us that Metasploit is figuring out how the web server responds to requests for pages that don't exist, hence the error code or HTTP status of web code 404. When it comes over here and says using 404 as not found for this private IP, it correctly determined that the server returns a standard 404 not error found, which is very normal. It tells us scan 1 of 1 host, which tells us that the scanning has been completed. And then when it tells us the auxiliary mode execution completed, it tells us that this particular module is done with its work. But the most important part that is missing from this result that ensures that our client or target VM was not exploited is that there are no lines that return back with found. If it found any details, that means it found vulnerabilities within our client VM. So that did not happen. So in conclusion for this quick order reconnaissance test, what we figured out is that our direct scanner call over here basically is using its default building words list, and in this case it did not find any common directories that it could exploit on our web server for the client or target VM. Now, is this a failure? It is not. It is a realistic result. In a real-world test, finding nothing with a default scanner attack basically is very common. It simply means the website does not use obvious directory names like /admin or /test or /backup or /uploads, which would have given a room for exploitation, most possibly. And so that is something that is very, very important. Now let us go and perform another quick and last test with a particular cybersecurity threat that is called the eternal blue. Before we kick off that process, let's quickly check up on the other session running. Perfect. We can see that this has now finally completed our SMB login brute force attack. When it finished that, after running for so many minutes, it told us as well too that the scan one of one host, 100% complete. The brute force process has been completed, and it tells us 0 credentials that were applied were successful. That means none of them were successful. And so that means that our server is still protected and has not been exploited because its password and user credential, the combination together, was not guessed by our penetration testing. Now we will jump back to what we were talking about, which is the eternal blue. Let's quickly take a look at what that entails. To do that, I'm going to open up a new web page over here, and I'm going to say eternal blue. And from this perspective, we're just going to put in the word wiki and hit enter. And that should bring up some information for us. So let's click on that. So it tells us that Eternal Blue is a computer exploit software developed by the US National Security Agency. It is based on a 0-day vulnerability on Microsoft Windows software that allowed users to gain access to any number of computers connected to a network. The NSA was aware of this vulnerability but did not disclose it to Microsoft for several years. Eventually, as we go down the line of the story, it tells us that on May 12, 2017, a computer worm in the form of a ransomware nicknamed WannaCry used the Eternal Blue to exploit an attack on computers that were using Windows that did not receive the latest system updates that can remove that vulnerability. This was because at some point in time, in 2017, NASA discovered that that software was stolen by a group of hackers known as the Shadow Brokers. And while that was happening, the hacker groups attempted to auction off that software. And so we begin to see the power of Eternal Blue and how it exploits a vulnerability in Microsoft's implementation of the SMB protocol. Now, let's jump into some real serious work. I'm going to head back over here to our Azure Bastion session. Before we kick off, our objective here is to identify and exploit the code word MS17/010, that being Eternal Blue vulnerability on Windows machine. So that if our Windows target machine does not have the necessary patching updates for Eternal Blue vulnerability, our attacker Kali Linux virtual machine here will successfully exploit it. And it will gain full system level control. The crucial prerequisite again for this is having an attacker VM and a target VM. But before we kick off, let's quickly run an Nmap scan, which is a networking tool that scans and detects different hosts and ports. Let us confirm that we can still reach to our client VM. I'm going to go ahead and initiate an nmap command. I'll target the 445 SMB protocol. Let's go over here to ensure we don't have more than the space needed. Perfect. And then I'm going to provide the target VM's private IP. So 172.18.0.5. And I'll hit enter on that. And then let's see. We can see that our port 445 is currently open on the target VM, which is a Microsoft VM. It tells us one IP address was found, which was the one we provided, and that host is up and running, and that was scanned under 20 seconds. So now that we know that the output state is successful, we can then go ahead to perform more critical actions. The very first action is we want to search our Eternal Blue module to see what we have going on in there. I'm going to say search and I'm going to use the code word for it, which is MS17-010. I will enter on that. Perfect. And it shows us different exploits and auxiliary channels or modules. One of them is the exploit Windows SMB MS1701 Eternal Blue that we can run as an exploit to attack the client's VM. The disclosure date of that is also provided. As you can see, that is aligning with the story we just read about the attack date on when that was initially used as an attack. Let's head back over here. We can see other exploits as well over here, as well as our different auxiliary modules over here as well too. One of the ones we're going to be exploring is this first exploitation over here, where we would launch an exploit using this module. So let's move on to the next task over here. Our next task is to then use this exploit. I'm going to come over here and I'm going to say use exploits. Windows SMB MS 17010 Eternal Blue. Do bear in mind that we can run all of these other modules provided over here. I'm going to go ahead and hit enter on this. Perfect. And now we've switched to that module. So now that we've switched to that module, I can then go ahead to perform attacks on this particular module. Do bear in mind that when we are using an exploit attack, we are basically and actively exploiting that vulnerability. Whereas when we are using an auxiliary module, we are checking to see if that attack is vulnerable. The auxiliary then becomes the soft attack and the exploit becomes the main offensive attack. And so let's move to the next course of action. Now for our next course of action, we're going to set our roast, which will target our machine. But let's see other key commands we have over here. I can run the show options so that I can clearly see what are the different options I have. I'll hit show options, hit enter on my keyboard, and it begins to show me some of the key options, such as the roasts. That is required. Some other options are not really required to run certain commands. It tells us that is the target host. We can read more on that using this link. We see the R port as well too. We can use that too. We've configured our SMB port number that uses TCP protocol. From this perspective, we begin to see other key details that pertain to our own private VM, such as our L host. You can see right there that is the private IP of my attacker VM. And so that shows us some key details. So now our next course of action is to now target our VM that we want to attack. I'm going to set roast on that. I would say 172.18.0.5. We'll set that. That has been set. Now I'm going to launch the attack. This time around, because we're using the exploit and we've broken down the difference between the exploit and the auxiliary, as well as how they relate to running a run attack and an exploit attack, I'm going to use an exploit attack in this scenario. I'm going to go ahead and type that in. Now I will launch the attack. We'll wait for that to complete. And we can see from the response back, even though that is still processing, and now that is done. So basically what we can see from this attack is that our attacker VM ran an Eternal Blue attack on our target VM, and it confirmed to us that the exploit is now completed, but the target is not vulnerable. It ended up scanning one host and it found that host. We can see over here it is running all of those actions. and it was not able to do what? To exploit our client or our target VM. This ensures and confirms that our target VM already has the vulnerability patching update it needs to ensure that an exploit such as Eternal Blue cybersecurity attack cannot overwhelm our target VM. Optionally, I can also run the other attack, which is called run, by hitting that right here. It will most likely bring back the same result. As you can see, the result over here correlates with the result happening over here. We'll wait for that to get completed. Now it is successfully completed, and we can see that they are both generating the same results, confirming that the target VM is safe, secured, and is not vulnerable to Eternal Blue attack. And so this marks the end of our quick free webinar in cybersecurity when it comes to penetration testing with Metasploit using Kali Linux server. Till next time we see you again, enjoy yourself and thanks for watching.